siphon is impossible and the tank has to be positioned below the collector, a pump has to be fitted. The pump will either be powered by 220 volts through a controller or by means of a 12 volt pump powered by a PV panel. The most common freeze protection device. This system uses a heat exchanger to transfer the energy from the heated glycol into the water. Heat exchangers come in many forms. Examples of these are a double jacketed water heater, an external heat exchanger, or an internal heat exchanger. The reason for using glycol in the collector is to remove the potable water from the freezing conditions. Another form of freeze protection in a direct pump system is the recirculation system, whereby the differential controller senses the low temperature of the collector and switches the pump on and circulates the warm water from the tank to the collector to prevent freezing. Retrofit systems are used when an existing standard water heater is adapted and connected to a solar collector. Evacuated tubes come in two different forms, one being a glass-in-glass type similar to a thermos flask, whereby you have the glass in a glass tube inside of a glass tube, and between the two tubes we have a vacuum. And then you have the evacuated tube with the heat pipe on the inside, which is a copper pipe with a heat transfer liquid inside of it, which has an absorber plate connected to it. In this case we have a 70mm tube with a selective coating on a fin connected to a heat pipe. Another type of heat pipe would be in the double glass type heat pipe. The tube takes the heat pipe on the inside on an aluminium fin, which transfers the heat from the inside of the tube or the evacuated tube onto the aluminium fin and then onto the heat pipe. The heat pipe's probe is plugged into a manifold such as this one. It's imperative to have a very good seal between the probe or the bulb and the manifold itself. Another form of evacuated tube system would be a low pressure system, or an instantaneous type system where the tube plugs into the tank directly and the water actually flows into the tube itself from the tank. On a flat plate panel we have an extruded aluminium casing. The glass covers an absorber plate connected to risers and two headers. The amount of risers depends on the size of the panel, and the size of the panel depends on the amount of water being heated. On every hot water system, the hot and the cold water should be balanced. The delivery pressure between the hot and the cold should not differ more than 20%. All valves on a hot water system should be of the same pressure rating. In this case we have an expansion relief valve at 600 kPa, it's green, and on this side we have a T&P valve which is red, which indicates that it's 400 kPa. These valves cannot work together. This is a pressure control valve. It has a pressure reducing valve and an integrated expansion relief valve. It is 400 kPa. It has a red label. This T&P valve would work with this valve together. A temperature and pressure valve has a probe which is inserted into the geyser, which has wax in it, and as the water heats up, the wax melts, and when the water reaches between 92 and 95 degrees Celsius, the little pin inside of the probe pushes open a jumper, releases the boiling water or the hot water, and lets in cold water from the mains. SANS 10254 states that the probe of the T&P valve needs to be a minimum of 25% of the length of the valve inside the body of the water being heated. In this case you can see somebody tried to make an extra port on the geyser, and this probe will not enter the geyser as needed. A vacuum breaker is needed on the hot and the cold side of the water supply to the geyser and the hot water out from the geyser. These are two vacuum breakers made by two different manufacturers. On the cold water side of the geyser, the vacuum breaker needs to be on a T above the level of the water of the geyser to alleviate the siphonage of the water out of the geyser when the mains is cut off.